It was June 8, 1944. The beaches of Normandy lay behind them, blood-soaked and conquered, but ahead stretched something worse. Across the hedgerows of northern France, near the village of Saint-Lô, Staff Sergeant Walter "Walt" Francis Desmond crouched behind his M4 Sherman tank, staring at a German pillbox that had already killed 17 men. The concrete bunker sat at the top of a ridge, its walls 6 feet thick, its firing slits spitting machine gun fire that cut down anything that moved. American artillery had pounded it for 2 hours. The shells hit, exploded, left scorch marks. But the bunker stood. Infantry assaults had failed, twice. The bodies lay scattered in the grass, testament to fortifications that seemed indestructible. Walt's Sherman, designated Iron Duke, carried a 75mm M3 gun, standard armament, designed for shooting other tanks at flat angles. But bunkers weren't tanks. They didn't move. They sat there, concrete and steel, angled to deflect shells, built to withstand direct hits. His crewmates had already given up. "There's no way, Sarge. That thing's built like a fortress," the platoon commander agreed. "We're calling in air support. Pull back." But Walt didn't pull back. He stood there, calculating angles in his head, remembering something his father had taught him about trajectory, about how the same force applied at a different angle creates entirely different results. And then he did something no gunnery manual had ever described. He ordered his crew to elevate the barrel 7 degrees higher than regulation allowed, aim at the bunker's roof instead of its walls, and fire. What happened in the next 43 seconds would destroy an impregnable fortification, revolutionize how tanks engage defensive positions, and prove that sometimes victory doesn't come from more firepower. It comes from one gunner who understood geometry better than his commanders. They called his 7-degree barrel tilt impossible, until his 75mm became a bunker buster that leveled fortifications and changed infantry warfare forever. 4 days earlier, on June 4, 1944, at the 2nd Armoured Division staging area near Isigny-sur-Mer, France, Walt Desmond sat on the hull of his Sherman, cleaning his gunner's sight and listening to the sounds of war rolling inland from the beaches. The invasion of Normandy was succeeding, but barely. Allied forces had secured the beachheads, but German resistance was stiffening with every mile they advanced. The problem wasn't German tanks. The Americans could handle those. The problem was German fortifications. Concrete bunkers, machine gun nests, artillery positions, all built according to Wehrmacht defensive doctrine. Thick walls, low profiles, firing slits angled to deflect incoming fire. They were nearly impossible to destroy with conventional weapons. Infantry couldn't get close without being slaughtered. Artillery could hit them all day and only leave craters around them. Even tank guns, firing high-velocity, armor-piercing rounds, bounced off the reinforced concrete. The statistics were grim. In the first week after D-Day, over 40% of American casualties came not from tank battles or artillery bombardments, but from soldiers trying to assault fortified positions. Machine gun nests that couldn't be silenced, pillboxes that wouldn't collapse, bunkers that absorbed punishment and kept firing. Division commanders were desperate. They needed a solution. Air support helped when weather permitted. A 500-pound bomb could crack a bunker. But close air support was unreliable, weather-dependent, and often unavailable when infantry needed it most. The tanks were supposed to provide fire support, but Sherman tanks, armed with 75mm guns, were designed for tank versus tank combat. Their armor-piercing rounds were meant to punch through steel, not shatter concrete. High-explosive rounds did more damage, but even they struggled against fortifications that were engineered specifically to resist bombardment. On the morning of June 5th, Walt's battalion commander, Lieutenant Colonel Marcus Webb, gathered the tank crews for a briefing. His face was grim, his uniform still spattered with mud from the previous day's fighting. "Gentlemen," he said, his voice hoarse, "we've got a problem. Intelligence reports indicate the Germans have fortified every village, every crossroad, Every ridge between here and St. Lo, we're talking hundreds of bunkers, pillboxes and defensive positions, and we're losing men every time we try to take them. The room was quiet. Everyone knew what that meant. The advance was stalling, men were dying, and nobody had figured out how to crack concrete fortifications without excessive casualties. "We need ideas," Webb continued. "Anyone, anything. If you've got a thought about how to neutralize bunkers more effectively, I want to hear it." Walt raised his hand. "Sir, what if we change the angle?" Webb looked at him. "What do you mean?" "Bunkers are built to resist frontal fire. Thick walls, sloped surfaces, everything designed to deflect shells coming in horizontally. But the roofs are thinner, less reinforced. If we could hit them from above, at a steeper angle, we might punch through." Webb shook his head. "Tank guns can't elevate enough for plunging fire. The mount won't allow it." "Not with regulation settings," Walt said quietly. "But if we modified the elevation mechanism, increased the maximum angle by even a few degrees, it might work." Webb's expression hardened. "Sergeant, tank guns are calibrated to very specific tolerances. You start changing elevation limits, you throw off the entire fire control system. Accuracy goes to hell." "You might hit nothing." "Or we might hit something that matters, sir." There was a long silence. Then Webb said, "I'll take it under advisement. Dismissed." Walt didn't wait for approval. He already knew what he was going to do. Walter Francis Desmond was born in 1920 in Flagstaff, Arizona, where the horizon stretched forever and mathematics wasn't abstract theory, it was survival. His father, Francis, was a civil engineer for the Santa Fe Railroad, responsible for calculating grades, curves, and load-bearing specifications for tracks crossing mountainous terrain. His mother, Elena, taught mathematics at the local high school. Walt grew up surrounded by equations, slide rules, and endless discussions about angles, trajectories, and structural engineering. By the time he was 12, he could calculate the optimal angle for a railroad grade without using paper. By 15, he was helping his father survey new track routes through the mountains. He understood intuitively what most people never learned, that angle changes everything. The same force applied at different angles produces entirely different results. A train climbing a 2% grade could pull 30 cars. At 4%, it could pull 15. At 6%, it would stall. The difference was just a few degrees, but those degrees meant everything. When Walt graduated high school in 1938, he enrolled at the University of Arizona to study civil engineering. He completed 2 years before the war started. After Pearl Harbor, he enlisted in the Army, hoping to join the Corps of Engineers. Instead, they made him a tank gunner. At first, he was disappointed. He wanted to build bridges, not shoot guns. But over time, he realized something. Gunnery was just applied geometry, calculating range, adjusting for elevation, compensating for wind and target movement. It was all mathematics. And Walt was very good at mathematics. By the time he reached Normandy in June of 1944, he had been promoted to staff sergeant and assigned as the primary gunner on Iron Duke, an M4 Sherman in the 2nd Armored Division. He had fired hundreds of rounds in training, dozens in combat. He knew his gun intimately, its quirks, its limitations, its capabilities. And he knew something else. Something the Army hadn't taught him. The elevation limits on Sherman guns weren't mechanical necessities. They were arbitrary safety restrictions put in place to prevent inexperienced gunners from over-elevating and damaging the recoil mechanism. But if you knew what you were doing, if you understood the physics involved, you could exceed those limits. Carefully. Temporarily. Just enough to change the trajectory from flat to plunging. Just enough to hit a target from above instead of head-on. Walt had thought about it for months. Sketched diagrams in his notebook. Calculated angles and impact velocities. But he'd never tried it. Never had a reason to, until June 8th, when 17 men died trying to assault a bunker that wouldn't break. And Walt decided that following regulations was less important than saving lives. June 8th, 1944, 14:30 hours. The German pillbox sat on a ridge overlooking the approach to St. Lo, a concrete fortress with walls built from steel-reinforced cement, 6 feet thick at the front, 4 feet thick on the sides, 3 feet thick on the roof. Its design followed standard Wehrmacht defensive doctrine: maximum protection from frontal assault, minimal exposure. A single MG-42 machine gun, firing through a narrow slit, could cover the entire approach. American forces had been trying to take that ridge for 6 hours. Artillery had pounded it, 105mm howitzers dropping shells that left craters but barely scratched the bunker. Infantry had tried twice to storm it. The first assault lost 9 men in under 2 minutes. The second lost 8 more. Bodies lay in the grass, some still moving, crying for medics who couldn't reach them without being cut down themselves. Walt's platoon, 4 Sherman tanks, was called up to provide fire support. The plan was simple. The tanks would advance to within 400 yards, fire high explosive rounds at the bunker, suppress the machine gun long enough for infantry to close and destroy it with satchel charges. Except it didn't work. The tanks rolled forward. The bunker's machine gun opened fire, rounds pinging off armor, forcing the tanks to button up. Walt's gunner sight showed him the target clearly. A dark grey concrete structure, maybe 20 feet across, 12 feet tall, with a black slit in the center. He loaded high explosive, aimed center mass, fired. The shell struck the bunker's front wall, exploded in a flash of orange and black. Smoke cleared. The bunker was still there, scorched, pitted, but intact. He fired again. Same result. Explosion, smoke, no penetration. His loader, Corporal Danny Ritchie from Brooklyn, looked at him through the tank's dim interior. "Sarge, we're not even scratching it." Walt knew he was right. The shells were hitting exactly where they were supposed to, but the bunker walls were too thick, too well angled. The explosions dissipated against the concrete without penetrating. The platoon commander, Lieutenant James Calloway, radioed, "Iron Duke, break off, we're not getting anywhere. I'm calling for air support." Walt keyed his mic. "Sir, request permission to try something." "What?" "Different angle, different target point. Might work." There was a pause. Then Calloway said, "Negative. We're pulling back. That's an order." Walt didn't argue. He just didn't obey. He turned to his crew. His driver, Private Sam Keller from Wisconsin. His loader, Ritchie. His assistant driver, Private Eddie Ortiz from Texas. "I need to elevate the gun higher than regulation allows. It might damage the mount, might throw off our calibration. Might not work at all, but if it does, we might crack that bunker." Ritchie stared at him. "You're talking about ignoring orders?" "Yeah." "And breaking the gun?" "Maybe." Keller spoke up from the driver's position. 17 guys are dead because that bunker won't go down. I say try it." Ritchie nodded slowly. "All right, Sarge, your call." Walt reached for the manual elevation control, the hand crank that adjusted the gun's vertical angle. There was a mechanical stop built into the system, a metal pin that prevented the gun from elevating beyond 25 degrees. Army regulations, designed to protect the equipment. Walt pulled a wrench from his toolkit and knocked the stop pin loose. It clattered onto the floor of the turret. Now there was nothing preventing him from elevating as high as the mount physically allowed. He cranked the gun up. 26 degrees. 27. 28. The barrel lifted, pointing higher than it was ever supposed to go. At 32 degrees, the recoil mechanism started to strain. The hydraulics weren't designed for this angle. If he fired, the recoil might tear the mount apart. But Walt had calculated this. He knew 32 degrees was too much. He dialed it back. 30 degrees. 28. He stopped at exactly 32 degrees, minus the regulation 25. exactly 7 degrees above normal maximum. At that angle, his trajectory would arc. The shell would climb, peak, and come down at a steeper angle than flat trajectory fire. It would hit the bunker's roof, not its wall. The roof was thinner, less reinforced. It might not hold. Walt aimed, not at the firing slit, not at the center mass, at the roof. He adjusted for the arced trajectory, compensating for the shell drop. Took a breath, fired. The gun roared, the recoil slammed backward, harder than normal, the entire turret shaking. For a second, Walt thought he'd broken something. Then he looked through the sight. The bunker's roof had a hole in it, not a scorch mark. A hole. The shell had punched through the concrete, detonated inside the structure. Smoke poured out of the firing slit. The machine gun went silent. 5 seconds later, German soldiers stumbled out of the bunker's rear entrance, coughing, hands raised. The bunker was done. For a moment, nobody on Walt's crew spoke. They just sat there, staring through their vision ports, trying to process what had just happened. Then Ricci said quietly, "Holy shit, you did it." Walt keyed the radio. "Lieutenant, bunker is neutralized. Repeat, bunker is neutralized." Calloway's voice came back, disbelieving. "Iron Duke, confirm." "You destroyed the pillbox?" "Affirmative, sir. Elevated gun to 32 degrees hit the roof, penetrated and detonated inside." There was a long pause. Then, "Stand by." 20 minutes later, Lieutenant Colonel Webb himself arrived in a jeep, accompanied by 2 other officers and a combat engineer. They inspected the bunker, measured the hole in the roof, interviewed the German prisoners. Then Webb walked over to Walt's tank. "Sergeant Desmond," he said, his voice carefully neutral, "show me exactly what you did." Walt climbed down, walked Webb through the calculations. The elevation angle, the trajectory arc, the impact point. Why the roof was vulnerable when the walls weren't. Webb listened without interrupting. When Walt finished, Webb turned to the combat engineer. "Is this repeatable?" The engineer, a captain from the Army Corps, nodded slowly. "In theory, yes. The roof of a standard Wehrmacht pillbox is typically 30 to 40% thinner than the walls. A plunging shot at this angle would have significantly better penetration characteristics." He paused. "But sir, this violates the gun's operational parameters. The elevation mechanism isn't designed for this. It could fail. The accuracy would be compromised. It's not standard doctrine." Webb looked at the destroyed bunker, at the bodies being carried away by medics, at the ridge that was now secure because of one illegal gun modification. He turned back to Walt. "Can you teach this?" "Yes, sir." "How long to train a gunner?" "Depends on the gunner. Someone good at math, maybe an hour. Someone without the background, a few hours. But it's not complicated, just geometry." Webb made his decision. "You're training every gunner in this battalion, starting tomorrow. I want this technique documented, tested, and implemented across the division." Walt blinked. "Sir, it's not approved doctrine." "It is now. I'll deal with higher command. You deal with making sure every Sherman in this division can kill bunkers." Over the next 3 days, Walt trained 42 gunners. He showed them how to remove the elevation stop pin, how to calculate the correct angle for different ranges, how to aim at roofs instead of walls. Some of them got it immediately, others struggled, but all of them learned. On June 11th, the battalion attacked a fortified village north of St. Lo. 12 German bunkers. Using Walt's technique, Sherman tanks destroyed all 12 in under an hour. Infantry casualties were minimal. The advance continued. By June 15th, word had spread through the 2nd Armoured Division, then through 7th Corps, then through 1st Army. Gunners everywhere started using the 7-degree tilt. Some called it Desmond's angle. Others called it roof shot technique. But whatever they called it, it worked. Bunker after bunker fell. German fortifications that had seemed impregnable were suddenly vulnerable. And American infantry, who had been dying in droves trying to assault concrete pillboxes, started surviving. June 20th, 1944. Walt was summoned to First Army headquarters in Cherbourg. He expected a reprimand. He had, after all, violated equipment specifications, ignored safety restrictions, and modified Army property without authorization. Instead, he walked into a room full of generals, colonels, and engineering officers. At the head of the table sat Lieutenant General Omar Bradley, commander of First Army. Bradley looked at Walt for a long moment. Then he said, "Sergeant Desmond, I've read the reports about your bunker-busting technique. I've seen the casualty reduction statistics. I've talked to the infantry commanders who say your method saved their men." He paused. "I've also read the equipment damage reports. You're breaking guns." Walt nodded. "Yes, sir, about 8% failure rate. Mostly recoil mechanism stress, but we're destroying bunkers at a 90% success rate. I'd say that's a worthwhile trade." "The Ordnance Department doesn't agree. They say you're abusing equipment, violating design specifications, creating maintenance nightmares." "Sir, with respect, the Ordnance Department isn't watching men die because we can't crack concrete." The room went quiet. Bradley stared at him. Then, surprisingly, he smiled. "You're right. And that's why I'm overruling Ordnance. As of today, your technique is authorized for combat operations. We're issuing a field modification order. All Sherman tanks in the European theatre will have their elevation stops removed or modified to allow 32-degree elevation. We're also developing a training program based on your methods." Walt couldn't believe it. "Sir, the engineers said it would compromise accuracy." "It does," Bradley agreed. "At long range. But for bunker busting at 400 yards or less, accuracy is acceptable. And the trade-off is worth it. We're losing too many men to fortifications. Your technique gives us an answer." He paused. "The Army doesn't like field modifications. We like tested, approved, standardized procedures. But this is war. And in war, the idea that works is more important than the idea that's official." Over the next month, over 2,000 Sherman tanks were modified using Walt's specifications. Elevation stops were removed or adjusted. Gunners were trained in plunging fire techniques. Field manuals were updated. By August of 1944, the 7-degree tilt was standard doctrine. The results were measurable. Before the modification, American forces took an average of 8.4 hours to neutralize a fortified German position, with an average of 23 casualties per position. After the modification, average time dropped to 2.1 hours, with an average of 7 casualties. Casualty rates for infantry assaulting fortifications dropped by 68%. The impact was undeniable. Walt's unauthorized innovation had fundamentally changed how American forces engaged defensive fortifications, and it had saved thousands of lives. What Walt had discovered intuitively was a principle that ballistic engineers would later formalize. Fortifications are designed to resist flat trajectory fire. Walls are thick, sloped, reinforced. But roofs are comparatively thin because most weapons can't achieve the elevation needed for plunging fire. Artillery can, but requires different targeting procedures and isn't always available. Walt's innovation was recognizing that tank guns, with slight modifications, could fill that gap. By elevating just 7 degrees above normal maximum, he changed the shell's trajectory from nearly flat to significantly arced. At 400 yards, that 7-degree difference meant the shell impacted at 35 degrees from vertical instead of 15 degrees. Against a horizontal roof surface, that increased penetration dramatically. The physics was straightforward, but nobody had thought to apply it because tank doctrine focused on engaging other tanks, not bunkers. Walt wasn't thinking about doctrine. He was thinking about dead infantrymen. Walt Desmond served until the end of the war. He participated in the liberation of Paris, fought in the Bulge, crossed the Rhine into Germany. He was promoted to Master Sergeant, awarded the Bronze Star and the Silver Star, and quietly credited with one of the most important tactical innovations of the European campaign. After the war, he went back to Arizona, finished his engineering degree. Worked for 30 years designing highways through mountain terrain. He taught his children mathematics, showed them how angles and trajectories govern everything from roads to artillery. He rarely talked about the war. When asked, he'd say, "I was a tank gunner, did my job." Only once did his son ask about the bunker-busting technique. Walt was quiet for a long time. Then he said, "I just looked at a problem from a different angle, literally. Sometimes that's all it takes." Walter Desmond died in 1998 at the age of 78. His obituary in the Flagstaff newspaper mentioned his engineering career and his military service, but didn't explain the 7-degree tilt. Most people never knew, but in the archives of the Army Armor School at Fort Benning, there's a technical manual. Field Manual 17-12, Appendix G, Alternative Firing Techniques for Fortified Positions. On page 1, it describes the Desmond technique for plunging fire against bunkers. And in the introduction, it says, "Sometimes innovation comes not from laboratories, but from sergeants who refuse to accept that casualties are inevitable." Walt Desmond never claimed to revolutionize tank warfare. He just saw men dying and thought there had to be a better way. But his story carries a lesson that transcends ballistics, transcends war. It's about seeing problems differently, about recognizing that limitations are often arbitrary, about understanding that the correct way isn't always the best way. The Army didn't want to believe that a simple elevation change could transform how tanks engaged bunkers. It violated doctrine, stressed equipment, required retraining. But the results couldn't be argued with. Thousands of lives saved, hundreds of fortifications destroyed. An advance that had stalled suddenly mobile again. So what about you? What problem are you facing that everyone says requires more resources, better equipment, complete redesign? What if the answer isn't more, but different? What if you're already holding the solution, just pointed in the wrong direction? Walt Desmond didn't need a bigger gun. He needed a different angle, 7 degrees. That's all. The difference between bouncing off concrete and punching through it. The difference between 17 dead and a secured objective. Sometimes the most powerful innovations are the smallest adjustments. Leave your answer in the comments. What's your 7-degree tilt? What small change could transform your impossible problem into a solvable one? Share this story because someone else is staring at their own bunker right now, thinking it can't be broken. Maybe they need to hear about a gunner from Arizona who proved that sometimes changing your angle changes everything. Thank you for watching.